attention. So we're not going to be doing a whole lot of anything that's crazy. Now, starting off with number 1, I want you to tell me, what are my x-intercepts? Are any of them special? Which one? The 3. Yeah, the little square. So I'm going to underline it. And now I'm going to plot them. Now, what degree are we looking at here? This is degree 4. Because I just count again. 1, 2, 3, 4. Done. So, degree 4. Positive or negative? Positive. So, yeah, it has to be going up like that. Okay? So, degree 4. And there's no minus sign there. What was that?
Degree 4 because there's 4 x's.
Yeah, because there's 1. This one counts as 2 because it's squared. And then that one other x. So, I got 4. Now, in the front, and all these x's are positive, and the number out front is also positive because there is no number there. So, positive degree 4 does go with both up. And so, I'm going to put little arrows up here. So, I've done the correct end behavior. I have the correct zeros. And now these two things really basically go together. The number of possible turns and the crossing or touching of the x-axis. If you do the crossing and touching of the x-axis correct, you've done the problem correct, okay? So the last thing that I do is I draw, and so am I crossing or bouncing here? I got 2 answers. What am I doing? I'm crossing because this one is not our bounce. So I cross and I turn. What am I doing here? I'm going to bounce because it's my double root. And then I turn. This is really tight. That doesn't look the greatest, but that's what it is. So that's our function. Okay. Doesn't matter how low I go. Doesn't matter how, well, that one does. Doesn't matter how low I go. So that's it. So I have now done the correct end behavior, correct zeros, and correct number of turns. Now, why does it not matter how far down we go? Because unless I actually calculate every individual point in this function, I don't know what it does. Right. So we are making sketches. Okay. So it's not like a line. Where like a line, I know every point on your line. And like when I'm grading it, it's like, okay, your line veered off and it can't do that. Like I know that. But here, unless we actually go through and plug in like 0, 0.1, 0.2, 0.3, unless we plug in all those data points, we're not going to know. All right. Any other questions? Number 2. This one's the eye opener. It's slightly different from the other days. So if I take a look at number 2, this is a degree 5. Is it positive or negative? Negative. Notice, number 1, I started with your x-intercepts. Number 2, I heard someone talking about the degree and I went with that. Does it matter what I start with? No. You can go with either. You have to know the information though. So, degree 5, that's negative. What's my behavior looking like? Yeah, it looks like this. Remember, if I would draw a line between those 2 arrows, that's a negative slope. Okay? So if I draw a line between those 2 arrows, it's a negative slope, which is a negative degree 5. Now, you've never seen this before today. You've seen this, I should say, before today. You just haven't seen it where you had to graph it. So let's talk about it. When I look at x plus 2, what you are really doing is going x plus 2 equals 0, and you solve it, right? So I minus 2 and I minus 2. And I get my x-intercept of negative 2 comma 0. We do the same thing here. I go x squared plus 16 equals 0, and I solve that. Now, guess who decided to come back for this? Now we're going one step further. What's the square root of negative 16? 4i. And I'm going to add that plus or minus in front of it. Where is I on the square root? Or, sorry, where's I on the graph? It's on a different dimension than our paper, so we don't actually have it. So, folks, you do not graph this. So it tells me my degree, but I don't do anything with it in terms of how we're graphing this. Now, I do need to look at this one. So x squared minus 16 equals 0. This one's nice because when I add 16 to the other side, I'm now taking the square root of a negative or of a positive number. So when I take that square root, I get x equals plus or minus 4. You've been doing that now for a whole chapter. You've actually been doing that for a lot longer. But so this tells me that I actually have 3 zeros. So after I solve that, that is telling me what is the x coordinate of each 0. Like I said, that's new. So do we got questions on that? If you see imaginary, you don't graph it. So you actually kind of want to see imaginary. You want to see it because it actually means you have less work. All right, so I'm going to go ahead and I'm going to graph those 3 points. Are any of those points bounces or double roots? No, they're not. So we just cut through every single piece. So there's no square on any of these. So I cut through, turn and cut through, turn and cut through. Now we said this was degree 5. How many turns does a degree 5 have? What are the options? 2 and 4. There's one more. 0. Now this one only has 2. So that's a good check to do. Okay? But that's where, like I was asked before, like, okay, don't we always have the max number of turns? And we don't, because sometimes we get imaginary solutions. Or there's other things that happen, but that's what we're looking at. So, any questions about that? Flip the page, or flip the other way, actually. So the 2 problems we just did were kind of review of 4-6. We're going to do 3 more problems. They're an extension of 4-6. So there's nothing really actually too crazy about it. I actually think these ones are easier because my graph is really just a sketch. I really don't need a whole lot of information on it. So the first thing that I see is I'm graphing something that has the following characteristics. It's a degree 4. So I'm going to just put this down. That's a degree 4. This is a degree 4. I could flip them, right? So I have a lot of options. So degree 4, it's got to look something like that. Basically, the big thing is it's not an odd function. It's not going like this, and it's not going like this. That's the big thing. Now it says it starts in quadrant 3 and ends in quadrant 4. Whiteboard. 12, 1, 2, 3, 4. What is that? It's a clock. So this is how I remember the quadrants. 12 o'clock is obviously straight up, right? 1 o'clock is quadrant 1. That kind of makes sense. Now quadrant 2 and quadrant 1 can't be in the same quadrant, so we kick 2 somewhere. So it makes sense that we'd either kick it down or we would kick it to the left. We actually kicked it to the left. This is always true. So it goes 1, 2, 3, and then quadrant 4 gets 4 o'clock. So 1 and 4 actually share the time that they're in. So that's how I remember it. You don't have to stress about this. It's just a reminder, just kind of getting it back in your brain. All right. But so it tells me I start in 3 and I end in 4. So that means my degree 4 goes like this, it goes down. Okay. So I'm going to start with that. So I got 2 arrows going down. It tells me I have a relative max at x equals -4. So a relative max also means I have a turn at -4. So at -4, I'm just going to put a dot. I'm going to put a dot right there. I put a dot right there. Gabe decides to put a dot right there. And Aiden decides to put a dot up here. It doesn't matter. Okay? We just have to know that we're going to have a turn at that said dot. Now the next one, it says I have an absolute max at x equals 3. So at x equals 3, I just need to go up higher than whatever -4 was. So I'm going to go right there. And that is also a turn. It has to be my highest point. And so then I draw. Now there's a million different graphs that would work here. You could go slightly up, slightly down. You could have your end behaviors pinched in. You could have them pushed out. There's so many different things you could do. But I just check. Is that a degree 4? Yes. Does it start in quadrant 3? Yes. Does it end in quadrant 4? Is it a relative max at -4? Yes, it curves right there, and it's a high point. And then is the highest point of the entire graph at 3? Yes. That's it. I'm done. I've matched the stipulations that I had. Questions? Number 5, it gives you an x-intercept and a y-intercept. I want you to plot both points. And then it says it is always increasing. Try to draw. Try to draw something that's always increasing and goes through those 2 points.
What does this mean, bro?
Doesn't matter. You could put it at 0. You could put it higher, but then it goes in higher. I could put it lower. Just have some turn there. Yep. It really doesn't matter.
Okay, I didn't know.
Yep.
Yeah, I missed something.
All right, folks. You should have these 2 dots down. And you should have, you know what? Oh, come on. Should have those 2 dots. You know, I could have a line. I could have a cubic or degree 5 or whatever. One thing I did see people in the other class doing that you cannot do is they went like this. They went up, and then they kind of flattened out, and then they turned and went back up. If I'm flat, I'm not increasing. Okay, so you can't be the green line, so I'm going to get rid of it. But that's the only thing. As long as you're going left to right, going bottom to top, you're good. Questions? Last one then. On this page. What does this mean? As x goes to infinity, is that left or right? It's to the right. F of x is going where? Up or down? Up. So this is as I go to the left, this is up. So that's my end behavior. That's telling me that. It tells me I have 4 x-intercepts, so it doesn't matter if you put an x-intercept here, here, wherever. It doesn't matter where you put them. You just need 4 x-intercepts. And then it says you have a relative max at y equals 3. Try to draw that in. Yeah. Yep. So that's it. So that's relative maximum and that 3 is the highest. So you could take both these points and drag them up or drag them down. Because you just look at that single spot. Is that a high point or low? High point. Yeah, it's a high point. So that means it's max. And I can go through that more with you if you want to. All right, folks. This is what my drawing would be. What's wrong with it?
No points.
Well, I crossed 1, 2, 3, 4 times. So there's points there. So there's 4 x-intercepts. What's wrong with it? It's not up to 3. Yeah. So my relative max has to be at 3. So I'm just gonna scribble that away a little bit, and I'm gonna go like this. Boom. There's 3. Turn down. Dot. Done. Questions? Last page. Last page of your notepad. All right. Is that odd or even? It's even. Yeah. So it's an even function. That means f of x is gone because we're just matching this. I can't match an odd to an even function. It doesn't work. So that's gone. Now, what degree is this h of x? Degree 4. What degree is g of x? It is degree 6. So 1, 2, 3, 4, 5, 6. Now, are these both positive or both negative? They're negative because of right there. So negative, negative. How many turns does our graph have? It has 5. Which function is it? It's going to have to be g of x because h of x can only have 3 terms. We have 5 terms. It's always 1 less, and then we go down by 2. So it's going to have to be g of x. Questions on that? All right, you tell me, what function can we cross off? F of x, g of x, or h of x? H of x? Good. So this is degree 4, and this has to be an odd function. So that's good. What's the correct one? The f of x. Why the f of x? Yeah, because it's positive. So this is a positive, could be degree 3, 5, 7, so on and so forth, could be anything. But it is going to be a positive one, so that negative 2 out front of g of x gets rid of it. So we're looking at f of x. What questions do you got?